In the last class, we were looking at how to write the equations of a network in a systematic way, and we concluded that in general you will get equations of the form G sub A times V equals I S, right, where this is the augmented conductance matrix and this is the vector of unknowns. And what are the unknowns? What are all the unknowns? All the node voltages and currents through the voltage sources. And likewise, this I S is basically a vector with information on all the independent sources. Does it make sense, people? Right? And even though this is called the conductance matrix, as we saw yesterday, all the entries there need not have dimensions of conductance. It's only that core part on the top left corner which will have all the conductances that are there in the network. If you had voltage sources and so on, some of those entries may actually be dimensionless, right? Now, and how do we go about forming the conductance matrix? This is simply nothing but the sum of what? Very good. It is simply the sum of the MNA stamps of all the elements. Correct? And yesterday we saw what the MNA stamp of a current source would be, what a MNA stamp of a voltage source would be, what the MNA stamp of a conductance would be. So let us quickly write down that stuff. So, this is node A and this is node B and this is a conductance G, and what do we have? We have this is the conductance matrix or the augmented conductance matrix. We allow for potential auxiliary equations and unknowns, but the only thing we need to be aware of is A B and A B. And what do you have here? G minus G minus G and G. Okay. So, then we saw what a voltage controlled current source would behave like. Let us call this Gm times Va minus Vb, all right. Okay, and how does the stamp of this look like? What do we do? The only thing that changes is this becomes C and. Is that clear? Then we were discussing the voltage controlled voltage source. Mu times VA minus VB. And how does the MNA stamp of this look like? We need an auxiliary variable now, right? The auxiliary unknown is basically the current flowing through the voltage source, which is Ix, and that is there in the unknown vector. And what comment can we make about the MNA stamp? They are in the rows C and D, and what are the entries there? 1 and minus 1, okay. And in the last row, in the A, B, C and D, what will you get? So, you will get minus mu, 1 and minus 1. All right. So, this is where we stopped yesterday, I believe. Okay. The next controlled source is the current controlled current source, and I am going to remember a current controlled current source always measures the current through voltage, a 0 voltage voltage source. So, this is 0 volts, and so this is Ix, okay, and this is mu times Ix. All right. And what comment can we make about the MNA stamp of this character? How many extra variables do we need now? How many extra variables do we need now? You. Do we need an auxiliary unknown, or is there an extra unknown, or do we? Why? What are all the unknowns that are there in the network? So, all node voltages, please remember that all node voltages and currents that are flowing through voltage sources, right, are all unknowns. So, now the question I am asking you is, do we have an extra unknown now? When you have a current controlled current source, is there an unknown, extra unknown that is introduced, that needs to be introduced? Yes, and what is that? That Ix is unknown, it is flowing through the 0 voltage source, and therefore, it also needs an extra unknown. So, you will need an extra row and an extra column for that. And after saying that, what comment can we make about the MNA stamp of the current controlled current source? So, this is voltage controlled voltage source, this is the current controlled current source. What comment can we make about the stamp? Yeah, what is the stamp? Do not jump to conclusions. So, in which rows will the last column have entries? C and D, and what will be the entry on C? In the Cth row? Minus mu, and Dth row? Plus mu, okay, and other rows on, I mean, in what all rows will you will have entries in all 4 A, B, C and D, because there is basically Ix flowing out of node A and into node B, and mu times Ix flowing into node C and out of node D. So, in nodes A and B you will have 1 and minus 1, and node C minus mu and plus mu. All right. And what comment can you make about the last row? The auxiliary, the extra equation that we get, what is that that relates the voltage source? VA equals VB or VA minus VB equals 0. So, you must get 1 and minus 1. Does this make sense? Pardon? Which is, I mean, see, you always, I mean, the assumption is that in a circuit simulator, what you always assume is that you measure current through a voltage, a 0 voltage source. Okay. It is also likely that, you know, you can just have an arbitrary branch current and make this mu times Ix a multiple of that arbitrary branch current, in which case it's straightforward to simply introduce an artificially introduce a 0 voltage source and add an extra node there, right, and the formulation just simply works. Is this clear? All right. So, and I'd just like to draw your attention to one fact, and that is that you know, do you see any you know, if you stare at these two MNA stamps, you know, what comment do you think you can make of the voltage controlled current source and the current controlled voltage the voltage controlled voltage source and the current controlled current source? If you stare at the MNA stamps, I mean, do you see anything at all?
Transpose plus AB and CD.
Huh?
Transpose plus AB and CD as well.
It is not the transpose, right? I mean, it is, please note that the MNA stamp is not simply the transpose, right? You also have to swap, you know, swap the rows, you know, A with C and B with D. Okay? This is just something that I draw your attention to. We will use this fact later on, right? At any rate, it looks very similar, suspiciously similar to the MNA stamp of the voltage controlled voltage source. Okay. The next thing is basically the current controlled. We have seen the voltage controlled current source, the voltage controlled voltage source, the current controlled current source, and the last man standing is the current controlled voltage source. And how will this look like? So, you have A, again we have a 0 voltage source, and this is 0 volts, this is Ix, and what are the, this is node C and node D, and this is some Z, some impedance times Ix. All right. So, all right. So, how many unknowns do we have now? You have 2 unknowns now because of, and remember that the current flowing through any voltage source is unknown or is an unknown, and therefore, we need 2 extra columns and 2 extra rows . Okay. And now, if you will tell me what we need to do, let us assume that this corresponds to Ix and this column corresponds to Iy. What do we do? So, between nodes Which of the rows will you have entries in the last but one column? In A and B, so that is 1 and minus 1. All right. And what else? And what comment can we make about the last but one row? Last but one row. No? I mean, the last but one row will basically be, quantify what's happening with that. 1 minus 1. So, VA must be equal to VB, okay, and we are done with one row and one column. In the last column, what do we see? There must be 1 and minus 1, all right, and what must you see in the last row? You see VC, what is the so VC minus VD equals or minus Z times Ix equals 0. So, what do you see? What is that equation? 1 minus 1 and minus Z and 0. I guess the entries which are not there are all assumed to be 0. So, this should be good. All right. Okay. Now, if I flip the ports, if I interchange A with C and B with D, what do you think will happen to the MNA matrix or the MNA stamp of this guy? First of all, what do you notice with respect to this matrix and this matrix? That is simply the transpose. Okay. So, if I flip the controlled and controlling ports, what comment can we make about the MNA stamp? What will happen to that last entry minus Z? Which row will it enter now? It will enter, it will enter here, and therefore, if by flipping the ports, all that you do is, if you flip the ports, what you basically have is the transpose of the MNA stamp of this guy, correct? Right. So, which of the controlled sources does flipping the ports result in the transposed MNA stamp? This is just an observation. Flip the controlled and controlling ports in which controlled sources? VC, very good, and CCVS, very good. All right. Right. So, if you transpose the MNA stamp of the voltage controlled voltage source, if you transpose its MNA stamp, what will you get? The two things that you need to observe here. If we transpose this guy here, what do we get? We will get please see this clearly. What will we get? So, you will get minus mu 1 minus 1, and which rows are there in, which rows are they in? A, B, C and D, and what will happen on the last row? 1 and minus 1, and they will be in the C and Dth column. Okay, all right. So, that looks suspiciously similar to this, but there is a small twist. What is that twist? I mean, is this the same as that? It is not that. So, so if you take the transpose of the MNA stamp of the voltage controlled voltage source, right, you get something which seems like a current controlled current source, but it is not. There is a twist, and that is the controlling and controlled ports are interchange the controlling and control ports. And then you will get the current controlled current source. Does it make sense, people? Okay. At this point, this is just an observation. Is this clear so far? And if you take the transpose of a conductance, if you take the transpose of the MNA stamp of a conductance, what comment can we make? Well, that is a symmetric matrix. So, if you take the transpose, it remains the same conductance. Is that clear? All right. With this background, so this basically you get a CCCS with ports interchanged.